This lesson will cover noble gas notation. So let's say we have something like silver that had 47 electrons. If we were to write this out, 1s2, 2s2, 2p6, 3s2, 3p6, so on and so forth, it is going to take a lot of time and a lot of space to account for 47 electrons. So noble gas notation is a shorthand step that we can do. So first I'm going to give you the steps and then we'll go through some examples. So first, we obviously need to find the element on the periodic table. So if we were doing silver, we would find silver on the periodic table. Next, we are going to go back. So we're going backwards, decreasing an atomic number, to the last noble gas. Noble gases are in group 8A. Whatever that noble gas is, the most recent one going backwards, decreasing an atomic number, we are going to write its element symbol in brackets. And then step 4, we will continue the electron configuration starting at the period after the noble gas. So first one, let's do barium. So group 8A. These are the noble gases. So step 1, we want to find the element on the periodic table. Barium is right here. Again, we don't want to write the electron configuration for 56 electrons. So the shorthand way, we find the element on the periodic table, and then we want to go backwards. We're going to decrease an atomic number until we get to a noble gas. So I'm going to go from 56 down to 55, down to 54. Xenon is a noble gas. We are going to write the noble gas in brackets. Once we have the noble gas in brackets, we're now going to continue writing the electron configuration starting at the period after the noble gas. So xenon is in period 5. I'm going to start here in period 6. So again, this is the S block. S starts at energy level 1. So this would be 1s, 2s, 3s, 4s, 5s, 6s. So barium is in the 6th period of the S block. And it is 1, 2 over. So instead of writing out a big long electron configuration, we can just write xenon 6s6. Remember, xenon is atomic number 54. So xenon is accounting for those first 54 electrons plus I have 2 electrons in that 6s orbital, which would give me a total of 56 electrons. Barium is atomic number 56. Let's try bromine. So again, step 1, find bromine on the periodic table. The closest noble gas to bromine is krypton, but remember, we want to go backwards. We need to decrease an atomic number. So I'm going to go down from 35, 34, 33, 19, keep going, 18. Argon. Argon is the most recent noble gas when we work backwards. We are going to put argon in brackets. Argon is in period 3. So we're now going to start writing our electron configuration at period 4. This is the 4th energy level of the S block, and S can hold 1, 2 electrons. 4s2. Remember, S starts at energy level 1, P starts at 2, D starts at 3. So this is 3D, and D can hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D10. Alright, once I get to the P block, P starts at energy level 2. So 2, 3, 4. This is 4P, and bromine is 1, 2, 3, 4, 5. 4P5. Again, we can do a quick check with our number of electrons. Argon, atomic number 18. It has 18 electrons. Plus 2 in the 4s orbital gives me 20. Plus 10 electrons in the 3d gives me 30. 5 electrons in 4p gets me to my 35 electrons. Let's do phosphorus. Phosphorus is atomic number 15, so it has 15 electrons. So again, step 1, find phosphorus on the periodic table. Step 2, work backwards. Decrease in atomic number until you get to a noble gas. Noble gases are in group 8A. Take that noble gas, which is neon, put it in brackets. Neon is in period 2. We're going to start the period after the noble gas, which is 3. This is the 3rd energy level of the s orbital, and s can hold 1, 2 electrons. Again, S starts at energy level 1, 1, 2, 3. P starts at energy level 2, so this would be my 2P, this would be my 3P, and phosphorus is 1, 2, 3. 3P3. Again, you can check your number of electrons. Neon is atomic number 10, 10 protons, 10 electrons. Plus 2 electrons in the 3s orbital, plus 3 electrons in the 3p orbital, gets me to 15 electrons. Lastly, let's do xenon. Well, xenon is a noble gas. Not allowed. A noble gas cannot be its own condensed notation. But that doesn't mean you need to write it out longhand. You don't need to write it starting at 1s2. We could still follow the same rules. Find xenon on the periodic table, go backwards, decrease in atomic number until you get to a noble gas. Put that noble gas in brackets. Start at the period after the noble gas, which is 5. This is the S block. S can hold 1, 2. The D block starts at the 3rd energy level. So this would be 4D. And again, D can hold 10 electrons. P starts at the 2nd energy level. 2P, 3P, 4P, 5P. So this is the 5P orbital. And xenon is 1, 2, 3, 4, 5, 6 in the 6th position. And again, we can always count our electrons. 36, 38, 48, and 6 gets me to 54 electrons. So we accounted for all 54 of xenon's electrons.